In this video, we'll learn the Pandas DataFrame. DataFrame is similar to the DataFrame in R. It allows the different columns to have different data types. A DataFrame in Python can be created from multiple things. One is, for example, just directly define it as DataFrame. Another one from a Pandas data series. PD series. PD series means just a 1D labeled array, could be row-wise or column-wise. You could also create a Pandas data frame with a Numpy array, either one-dimensional or two-dimensional. And that could use a dictionary to create a data frame. In fact, using dictionary to create a Pandas data frame is the most convenient way to use it. For specifying a Pandas data frame, you can also specify the row name and the column names. The row name in Python is referred as index, and column names are still column names. Let's look at some examples. Here, let's first import the Numpy and the Pandas package. The Numpy is imported as NP, and the Pandas is imported as PD. By the way, if you have not installed, you need to first install the Pandas package before you can use it. To install that, you can do the pip install Pandas. This has to be outside of the environment using the blank CMD window, for example, like this kind of window, pip install Pandas. Or when you're in the Mac computer, use the script window to install. So that's for the Pandas. And once we have the Pandas installed, use the import to import it. And when we want to create a Pandas data frame, we use pd.dataframe. Here, this is that means that this is a function defined for the class called Pandas. And this function, we have the capital D, capital F. In this example, we have a 2D array here. So you see that's a 2D array, 0, 1, and 0. For this 2D array, we are using the index equals row, columns equals C1, C2, or C3, which means that we're having 3 columns, 1 row. And the result is a data frame that has 3 columns with 1 row. Next example, A is specified to have an NP array of 2D NPM array. And then afterward, we use pd.dataframe. And in this case, we want to specify the row names and column names. The row names, we use index to specify, and columns, the column names, we use columns equal to specify. So once we do that, if you try to print this data frame, you can see the row name as row 1, row 2, and column names V1, V2, V3. The Pandas data frame, if it's numerical, you can easily convert it to Numpy and do a lot of calculations with the Numpy. But some of the functions in Numpy can also directly be applied to the Pandas data frame. But if in case you do need to convert to Numpy, you use this dot to Numpy to convert it. Why do we need to convert to Numpy? This is because sometimes when you write some of the operations, your function is defined in the Numpy array. And when you try to operate it, you still have to use the same data type when you feed it to the function. And that's why you have to convert it to the Numpy. So this will just turn it to the Numpy array, the dot to Numpy, okay? So this example, we created the Pandas data frame from a Numpy array. The next example here, create a Pandas data frame with this kind of PD series. But first, let's define the PD series. The keyword is PD.series. this just means that we're going to have one row or one column, depending on whether you specify the index. In this example, we have three values, 1, 2, 3, and we use index equals R1, R2, R3 to tell that 1, 2, 3 are put together as a column. They have the row name of R1, R2, and R3. So in this case, we are using the tuple to give us the data. You could also use the list, like in next example, and the index could also be tuple, like here. All of these three will give exactly the same result. The next one here, we have Series, and you use a dictionary. And this dictionary has three elements. Each one has the name, like R1, R2, R3, and corresponding values. All of these will give us the identical single column Pandas data frame, but this is referred as Series. This Series is just like the 1D Numpy array. You can also use those functions to run on it. But because this Series, it has the row name here, you can also take out the value like you do with the dictionary. For example, here result with quotation mark R1 will take out the R1 value, which is the 1. And if this one is treated just like in the dictionary, here's the name, the key for the dictionary. And as we learned for the dictionary, if we directly use a key, but the key does not exist in that dictionary, we'll have an error. To avoid that error, we can use the .get to avoid that. So here we could do the same, use the .get, and then if we want to ask for R4, if we simply say result.get with quotation mark R4, it will return nothing because we do not have R4 in this variable R result. So in that case, in some case, you don't want to just return nothing. You want to, for example, here, if you couldn't find it, give a value called not exist. So in this case, R4 does not exist. It will return not exist. Okay. We can use multiple tuples to create or list to create the Pandas data frame. Here is an example. M is a list, N is another list. Each contains 3 values, and we can use the tuple of M and N together and use it to create the PD.data frames. When we put the tuples like this, each one of them serves as one row, like 1, 2, 3, that's the M, and 10, 20, 30, that's from the N. So they are used as the row of the data frame. On the other hand, if you want to use M and N as the columns of the data frame, in that case, you would use it like in a dictionary format. Here is the example. We first specify DAT to be a dictionary. So V1 comes from M, and V2 has value N, and then afterward we use PD.dataFrame with that dictionary in it. That creates the data frame with the V1 and the V2 and the corresponding values from M and from N. So that's to create the Panda data frame with these tuples or from a dictionary. Sometimes our computational process will incrementally create more entries or values, and we need to collect them together into the data frame. In that case, we can use these np.append to the Numpy array, and then afterward convert it to the data frame. So here's an example. We start with np.empty, which only gives the dimension. So here the number of rows is 0, number of columns is 4. So basically we specified the number of columns to be 4. And then we do a for loop. In this for loop, we make I goes from 0, 1, 2, 3. and this 0, 1 to 3 is given by the range of 4. Afterward, we use the NP data array to include to define this one row of the data. Even though it's one row of data, we have to define it as 2D array here. That's because when we want to append them together, even to final product, what we want is like in A, it has to be a 2D array rather than 1D. So this has to be the 2D, okay? So with that 2D array, we can use this np.append and the initial A, then we use the previous generated this variable, and we specify x is equals 0, that will put each of the rows to the A. So A will incrementally increase the rows. And then at the end, we use the pd.dataFrame on A that will create the data frame. So this is to incrementally add rows to the data frame. We could also use the multiple PD series to generate the Pandas data frame. And here's an example. We have a result and result 2. Both of them are just 1D PD series, but they have the same column name, the same row name. Row name are the R1, R2, R3 is given by the index. So that's the result. And for result 2, this is given by this dictionary. The row names are also R1, R2, R3, R4. And then afterward, we would use the pd.data frame, and then we put the column name here, and then this is the value for that column that's from the PD series, and then another column name and corresponding value from a second PD series. This basically specified the 2 columns of the data frame. Beyond this way, we could also do it like this one. This is the pd.data frame, and then we use the dot from dictionary, from dict underscore dict. When we do this, beyond here, this part is identical to the previous ones, like using a dictionary. We also have the option of specifying the orientation. So the orient here. Orientation, if you specify to be index, that will treat these 2 as the row of the data frame. Like this D0, D1, both of them are putting 1 and 2 as the 2 columns. But on the other hand, the D2 here, because we specify the orient equals index, so we have the 1 and 2 are treated as the first row and the second row of the data frame. One thing I would like to mention is that when you have these PD series of different lengths, like this example, result has 3 values, result 2 has 4 values, and when you try to combine them together into a data frame, it will try to adjust to the biggest dimension. So like the second one has 4 entries, so it will end up having 4 rows for the data frame. But because the first PD series only has 3 values, then an NaN is created for the last entry there. Similarly, when we put them into the row, we'll also have a NaN created because that only has 3 values for the variable 1. Okay, that's to create the Pandas data frame using pd.dataframe or using pd.dataframe from dictionary. Both of them could use the pd.series or use the Numpy array to create the columns. For a Pandas data frame, we can delete like columns or take out a column or even create a new columns. So how do we do that? If you want to delete a column, you simply just write this is the data frame name, and then you put a quotation mark inside of the square bracket. And in the quotation mark, you put in the name of that column. That will delete that column. So if we go back to look, here is our D. The D contains the D, okay. Oh, where is the D? Oh, I do not. Okay. That's the generate. Here is the D. So D on the right hand side here, the D has is a PD data frame created from dictionary, and we have the 1 here is the 1, 2, 3, and 2 here contains the -1, -2, -3. And the orientation is the index, means we're going to put these 1 and 2 in the row, and specify the columns to be R1, R2, R3. Okay. So that let me put this onto the next line. So you put a slash, just indicate that you're going to have a next line. Return. Okay, so that's the D after the, oh, wait a second, still you cannot see. So I'm going to put this orange also down. Okay. This slash is good to put in there because your command will continue to the next line. So we have the D specified, and then when you print it, you see these are the column names, and the 1, 2, that's the row name. And then when we try to take out delete one of them, you can just use the DEL and D with the name of the column. So the DEL here will delete that, but what's returned is the D itself, that the D itself has that column being deleted. If you do not just want to delete, instead you want to take out that column and meanwhile doing the deletion. In that case, you use the pop command. Like this example, you use d.pop, and then I put R3 column name there. Then what will happen is that this 2D data frame will become just the 2 columns. So R1, R2 will be kept in the D, and the R3, that one will be popped out. So what's returned from the D.pop is that R3's column. This is the D.pop. And meanwhile, the D also had this corresponding column being removed. So that's the .pop. So as you already saw, the .pop and the .delete, the .delete just simply delete. I don't want to delete yet because I still want to do the query. After the query, we'll try to do the delete. Okay. How to create a new columns for a data frame? You can do that by using the .assign. Here is an example. So .assign will create a new column, but it's not going to be put into the D. The D itself is unchanged, but the D.assign will create a new data frame. In this example, I have the R here being computed as the R1's column and R2's column's product. So if you look at this D.assign, it creates a new data frame that has 3 columns with the R as the last column. And if you print the original D, it still has those 2 columns after we popped the R3. Okay, so that's .assign. You might involve some of the conditions. Say you do not want to take out all of the rows. In that case, you can use .query to help to restrict to only part of the rows. This in the .query, you put conditions there. Like this example, I'm going to take out the column, the rows of the D such that the V3 column is greater than 4. But beyond that, take out those rows such that the V3 is greater than 4. What I want to do is that I want to generate 2 more variables. One is called the V2 square, and the other is called a V1 cube. Even though it's called a V2 square, the operation is defined here. What is the operation? It's a lambda x, which means it's a function. This function has only 1 line of the expression to define this function. And x here simply refer to the variable itself, the D itself, okay? So this means that I want this function to calculate this V2 to XOR. This caret 2 means bytewise XOR. What does bytewise XOR means? like a 5. Like for example, this V2 has value 5. For the 5 with the 2, the 5 in the binary representation is 101. That's because the last digit represents the 1 times 2 to the power of 0. And here is the 0 times 2 to the power of 1. And this is the first digit is the 1 times 2 to the power of 2. Altogether give us the 5. Similarly, the 2 is represented as 1 and 0. This bitwise XOR will operate like this. The 1 and 0, because they are different, the result is going to be a 1. And 0 and 1, they are different, the result is also a 1. 1 with 0 also a 1. So in the end, what we get is 1, 1, 1. And 1, 1, 1 represents 7. So you see the 7 being given here. So bitwise XOR basically will give a 1 if the 2 bits are different and 0 if they are the same. That's why in this case, they're all the ones from the 5 and those from 2, they're all different. That's why in the end, we got 1, 1, 1. The next example is 8 with 2. 8 and 2, when you do the bitwise operation, the 8 will be represented with the 8. Okay, it's 1, 0, 0, 0. And then for the 2, it's the 1 and 0. And then when you do the 2 together, you are going to get a 1, 0, 1, 0. Okay, so and in the end, what you get is 1, 0, 1, 0. Because 0 and 0, when they are the same, you are going to get a 0. When they are different, you will get a 1. So when it doesn't exist, you treat it as 0. So 1, 0, 1, 0. And that 1, 0, 1, 0 represents 10. That's why you see a 10 here. Similarly, this one, it was cut off. What's left behind is x dot v3 carried 3. So that's what's missing there. So basically, it's the bitwise operation of the v1 with 3. And that gives these 7 and 4 as the value. So those are the newly created columns, the v2 square and v1 cube. Afterward, select only the rows such that the v3 is greater than 4. So that's why you see here the 6 and the 9. Those are there. That's because that is greater than 4. Okay, so that's the creating new column or take out the sum of that. And when we try to index the data frame, this is more complicated than the ND array. So what is complicated? For selecting a column, you have to use the name of the column. So here, when you have the data frame name, let's say the data frame name is DF, and then you have a column name, you use the DF square bracket with that column name to take out that column. And if you want to select one row, you need to use the row label, for example. In that case, you have to use this .loc means location, df.loc with the label. And on the other hand, if you're using an index number, for example, first row, you can just use the df.iloc with square bracket 0 to take out the first row. If you want to have multiple rows, in that case, you can use directly, this is a range of these index values to take out the multiple rows. Or alternatively, you can use those locations like previously we do the dot query, specify the condition, which will create a true or false. And these true or false Boolean values, vectors, could also serve as the thing to help us taking out the rows. So that's to take out the row or columns of the data frame. Let's look at this example. Here we have a PD data frame. We have these 2D arrays, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the columns names are V1, V2, V3, and the row names are row 1, row 2, row 3. And let's say if we want to take out the first column, we use the D with the quotation mark V1 in there to take out the first column. And if we want the second row, then we do the T with the LOC with the row 2 in there. Or alternatively, we could also do it with this ILOC, then we put in the number index 1 to take out the second row. If we put in the index like 0 to 2, that'll take out the 2 rows, the first row and the 0, and the row corresponds to index 0, and the row corresponds to index 1. So that's the first 2 rows. We could also do a transpose, for example, then that's the D dot T or D dot transpose. So this will transpose this data frame. Element-wise, the operation for the Pandas data frame is similar to the NumPy. Basically, many of the functions for the NumPy that conduct element-wise operation also works for the PD data frame. For example, you can do the log, like np.log, or exponentiation np.exp, or square root, do np.sqrt, and so on. Those can be used directly on these PD data frame or PD data series. PD series. Here's an example, np.exp, you directly put the data frame D in there. Or sometimes if you actually technically require the specific type such as NumPy array to operate, then you do need to convert it to NumPy array by putting this dot to NumPy in there. And sometimes you also might need to change the data. Sorry. In that case, yeah, if you also need to change the data type, then you can do np.asArray, and you put in the data frame, and you specify the D type. And this D type we already learned earlier. You use those like integer, float, and so on to specify. Okay, so that is the NumPy array and the data frames relationship. There are quite many of those functions that's defined for the Pandas data frame. As you imagine, like this slide shows that those functions applied for NumPy's element-wise operation also works for the data series, the data frame. Therefore, if you try to look at these attributes or properties of Pandas data frame, they are also in there. Beyond those, there are additional ones that's specific for the Pandas data frame. One example is this 2CSV. So if you have a Pandas data frame, for example, the D, capital D, defined previously, then we can use the D.2CSV, and in parentheses, we give the name of the file. It will write the data frame out into the file. There are many others that could be used. This is good for importing and exporting data, but generally, if you want to do computation, it's still better to work with the NumPy array. Okay. So that's about the Pandas data frame. So previously we mentioned that the pop and the DL. So we did not do it over here. This was because I want to capture the rows and columns. So when we did the D.pop, so okay, let me rerun. So my D contains these 3 columns, 2 rows. When I do the D.pop, let me comment this one out so that you see the D.pop. The result of that is just 1 column, that R3 column, which contains the 3 and -3. And if I want to print what is the D, let me put it on a new one. The D would already have only the first two columns without the 3rd column. That's the D. And if we want to do query is to put conditions so that we can take out only the rows of the D. Here, for example, I put the condition of R1 greater than R2. That'll only takes a row such as R1 greater than R2. So this row is not satisfied, but the second row is satisfied. The result give me just the second row. Okay. The next that I want to do is to use this, like here's the example, the data assign. That means we're generating a new data frame, right? And in here, the variable is called R1SQ. And how is this one calculated? It's calculated as a function of this D. And we use X as the input argument, and the X is the R1 variable, calculate the actual square. So that'll calculate R1 square. And this is the result of this D data assign. It's a new data frame. Okay. And here, let me give this D data assign, call it a little d. And this little d, I will be able to say, let's say now the little d, if I want to do something like a d dot del, and I want to remove the R1. Oh, d.del, okay. Let me see. Oh, sorry, it's del and then the d. del and the d and the square bracket R1. So when I do that, let's print it. Print what we want to print is the d. So that's before that, let's print the d before we do the delete. This one, it shows what's in the D. It has 2 rows, 3 columns, and then afterward we do a deletion of the first column. And now let's do this print of D. So it end up having only the last 2 columns left. So that's that del. In the del command here, when we do the deletion, we don't really take out that R1's column. If you want that column, you need to use the d.pop of R1. Okay, so that summarizes what we learned in this video is the Pandas data frame. The data frame allows different columns to have a different data type. You can create a Pandas data frame with the pd.dataframe command, and what's inside would be like a list, tuples, or Numpy arrays. You could also use PD series inside of there to generate this Pandas data frame. There's also the pd.dataframe from dictionary command. That command allows you to specify the orientation to be indexed so that the data will be arranged in a row. Okay, so that's all about the data frame.